Okay. Um, okay, we're live. Sick.
Cool.
All right. A little bit of technical difficulty, but we're here, and it'll be worth it because we have a very good show. I'm stoked for this week because these are three tools that I actually use and really, really like and love the founders of, and we have the founders of all three of the tools here. Um, these are very open source friendly, highly scalable products that kind of fit into like a real world production system for both like data intensive applications and ML intensive applications. They're all very quick to pick up. And so this should be a really fun session because you can kind of take all three of these tools and build a pretty awesome scalable data system. So it'll be really fun. We have Pranav from Mooncake, we have Simba from Featureform, we have Maarten from Pycafe. I'll let all of them do their own intros and then we'll chat at the end. And these are all, I think, new tools to each of the founders to each other. So it should be a really fun session. Um, cool. Are we ready to kick it off?
Yeah.
Sick. Sick. All right, Maarten. Why don't you share your screen and then we'll
Yeah.
kick it off with you.
Yeah. Okay. And Ben, feel free to like interrupt or like give your like opinion of or thoughts about like how you think you can use Pycafe. I know you have some ideas, but let's start with my talk. So the title is Pycafe helps you build data apps quickly and scalable. Kind of the subtitle, kind of what describes is what if deploying a Python app was as simple as a single click and came at zero cost. So I hope that's sparks your interest a little bit. Yeah, so let's talk about a little bit like what the team behind this is. So I own a company, Bidgetti, a consulting company, and we're kind of doing the execution of the Pycafe, what I'm about to show you, together with Mario and Isaki. But the Pycafe project is a project together with Jack, former CEO of Plotly. So then you have a bit of an idea of the background of us. So I'm gonna talk about like what is Pycafe, for who it is, kind of the a few use cases that I will discuss, and I'll lay out more details on two particular use cases. That should give you a pretty good idea what Pycafe is and how you can use it, and then maybe Ben has some ideas on how you could use this as well. So let's start with like what Pycafe is. So it's a platform to create and share Streamlit, Dash, and Python apps online. So you can go in your browser to Pycafe, and then you should see a screen like this. You have tiles for all the big frameworks. You click on it. In this case, we click on Streamlit, and what you get is kind of like an integrated IDE in the middle. You can open your files or drag in new files on the left in the file browser. You have a preview browser here and a terminal. And all of this runs in the browser. And with that, I don't mean like, hey, there's a Docker image running on a virtual machine somewhere, and this is kind of the interface to it. No, everything is running on the browser. There is no server. It's running on WebAssembly, and in particular Pyodide. That's basically a Python version compiled to WebAssembly. And with the platform, you can edit. So you have an editor, you can preview it. I'll show some of that. And it's really easy to share. So I can probably share a link with the people here in the chat, and you should be able to see this app. You can have it full screen, although with the header here, if you want to share this with other people that are non-technical people that just need to see the output. And this scales infinitely because there's no server. So that also means there's basically no cost of running this, except a little bit of our servers. We support 6 frameworks, like the big ones like Streamlit and Plotly Dash, and a few others like Plotly, Visceral, and Panel, and Solara because I'm the creator of that framework, which I think is one of the best frameworks for building more um, like complicated applications, larger applications. Um, and we hope to have support for Gradio in the future and possibly also Jupyter. We made some real progress there. And you can create an unlimited amount of apps actually. So I created already, I looked just before this talk, I have created 300 apps on Pycafe. And if you go to my profile page, actually you see all of these apps. None of these are kind of like running, but they're live. Like if you go to my profile page, you click one of them, it will start running in your browser. But there are no 300 servers running somewhere that is costing me a lot of money. And also an interesting point is that it's kind of a safe sandbox environment in your browser. So if you want to use like AI LLMs to execute code, you can just let them run arbitrary code. And the worst thing that can happen is that the virtual environment in your browser gets corrupted. But that's it. And with that, I could end here, but because that's basically it. But let's go a little bit into the details. So I've shown you the screen before. So we have the editor on the center, and where do we store like this data? So when you initially start a project or a snippet, what we call it, all the data is in the URL. So that's what we call snippets, and they're URL encoded. They're quite limited in size. We also don't support screenshots, so you saw some screenshots on my profile page. That's not supported here. But these URLs, you can imagine, you can generate these from like your CI jobs, from scripts, etc. And this is all documented here. Also, we don't require login. I'm logged in here using GitHub now, but no need to log in if you don't like that. And there's actually no data being stored in our servers. But you can also create projects that does require a login because we need to know like who you are. You can have really nice URLs. Projects can be forked, kind of like GitHub. You kind of like clone or fork a project. But of course, these are stored in our database. But we can support larger sizes, up to 10 megabytes in total. And what's really nice is that because we can associate screenshots with project, if you share it, in this case on Slack, you get like a nice preview, a social card. And all of these screenshots that you associate to a project, you can visualize on your personal page. So in this case, this user has created like 5 screenshots for 5 projects, and you have some idea what you will see if you click on this app. So those who know me know that this is my lucky slide. So if I use this, a live demo never fails. So let's just see what happens. Live. So I click on Streamlit. You see that here I have my code. On the right, it's already like running. This is like real Streamlit for those people who know. So let's remove some of this. So I save it. And this is what you're used to seeing in Streamlit. So we say always rerun. Let's get rid of this. Streamlit on ML apps. So we save this. And we now have an interactive app that is like a real Streamlit app. We can go full screen, so we can actually share this app with other people. Like I can give you this link, and it will be like a full screen app. You can go back to the editor, or if you're logged in, you can turn this into a project. Wow, nice name, Streamlit MLOps. You can also, I shouldn't do this because this goes wrong with screen sharing, but you could in theory add a screenshot to this. Maybe you're wondering, what about data? So you can drag in some files like here. So now I added a CSV file. You can just browse it, push it to the cloud, and everyone would see this, and you could like do some manipulation on this data frame, etc. Okay, we survived. Always works. So for who are the users of this? So I'll focus on 2 things. So one is GitHub or GitHub integration. But you can also think about like ideal for teachers, like no setup is necessary, like no Conda, UV, etc. that you need to install. Just one click and it works. Like online sharing live examples with a nice social card. Startups is also, it's very lean, like nothing to maintain, no DevOps needed here. data scientist, kind of the same. And I'll go in the end a little bit into like why this is interesting for companies. So I'll focus on these two and skip the rest. So for open source and users, it's basically for us, it's a communication tool. So I maintain a few open source libraries, and we use it for like answering questions on GitHub, opening issues with reproducible examples. So let me show you how that works. So someone opens an issue on GitHub. This is a real use case, like someone did this. Does Solara provide access to browser's local storage? So I can give a very detailed technical answer here, or I just create a Pycafe example where I give a full working example. I give an answer with a link to this Pycafe example, and kind of you're kind of done. So what happened here? So I created an example to answer a question. It's fully reproducible. It's not like, hey, this works on my machine. And I started from a clean working environment, not my dev environment where everything works. But people can really reproduce it. And they can, if they click on this link or you click on this link, you can edit this, hack around, fiddle with it without having to like have like many steps. Another use case which is very useful is kind of like playgrounds or previews for PRs. Is that if you go to this project that we maintain, IPy and you open a PR, a pull request, and what you see is that we can generate a link to a playground for each PR. So you open a PR, you do some changes. There's actually a link here. You can click this, and if you click this link, it will install the PR or the artifact that was produced in this PR. So you can kind of like test, like, okay, this change, does it really do what this person did? So you can do some visual testing or maybe like some API checks, etc. It's very convenient. You can have like 100 PRs open, and there's not a single server running. There's only these URLs that will install this on the fly. So there's like zero cost, no emission maintenance whatsoever. If you're interested in this, and I think Ben was quite intrigued by this. On these in these links, you can actually read a little bit more about this. Then a little bit about the like enterprise self-hosted. So let's talk a little bit what our business model is. So we want to be open about this. So our public Pycafe server is not open source, but we support open source. We also sponsored like the Pyodite project, which is fully open source. We have a free plan. And with this free plan, you get you can publish open source projects. So you can have unlimited projects as long as they're open, like for everyone to see, kind of as a resource for others to learn. We have a pro plan planned that might enable like private apps and larger file sizes. But what we're also doing is to have an enterprise or a self-hosted version of Pycafe. So you have your private server, and this of course costs some money. So if you're interested in that, take a look at this page. So what is it? So it's an on-prem self-hosted server. It's a Python server. You can pip install it actually today. Maybe you wondering like, why would you use this? The reason is kind of like security privacy reasons. Like instead of having to trust us, you can just pip install this and run this on your own infra, and that makes adoption really like convenient. You basically don't have to trust us, and it's just a pip install. So if you're allowed in your company to run like Python servers, you can run our Pycafe server. You probably wouldn't even need to ask for permissions. And it's usually the case why people want this, because they cannot distribute the apps and they're only used or suitable for internal sharing. But maybe for some of these use cases also the pro plan would work. To understand a little bit what's going on, I created this graphic. And going back to the initial like snippets where you have this long URL, so everything is in the URL. So in the cloud, we have our Pycafe infra with a web server. So if you go to Pycafe and then the snippet link, we always fetch the HTML JavaScript from the Pycafe web server. But the data, like even like the CSV file, in the case that I demoed before, the data is stored in the URL and it's not stored in our database. The database is not being used in this case. But if you create a project, actually the data is on our database. And so instead of using the Pycafe server, you may be thinking like, okay, let's run our own Pycafe server at our custom domain. You run it yourself. But that's not always the right solution for some companies. And for that, we actually have a third method of like where you store your data. And it's kind of similar to snippets, where, but instead of like having not using the database, there is no database. And we only use your custom Pycafe server to host like the HTML and JavaScript. And you can export your application to an HTML file. And that's fully self-contained. So this is a file you can like put in your like Dropbox or Box or send by email or some kind of like file sharing application. For some people that makes fully sense, the right-hand side. For me, it did not when I first heard this. So let me explain for the people that also didn't like fully understand why would you do this. And the reason is why would you store files? Because secure file storage is a solved problem in many companies. Like companies know how, and many companies know like, okay, this is very sensitive data, so I like store it there. I can share it internally using this service. They know how to handle this. While a new database is always a bit tricky. It's very clear what the data is, and the idea of like being able to send a app via email is a very powerful idea. It's like kind of similar to sending a PowerPoint via email. Now you can send like full apps via email. I want to give a very small demo of this. So what you would do is we have our previously created app. We go to share, export, download as HTML. Already has a nice name. You can now see that we have this simple HTML file, 33 kilobytes. So it contains this CSV file, and we can now open this in the browser, and it should run. Of course, this trial version, so you get this header. But as you can see, this is a fully, well, except need to give permission, but this fully working example. Okay. I need to wrap up. So if you want to see some more information, there's a nice video about how to use Streamlit with Pycafe. Also on Plotly, there's a nice example using Visro. There's some more in-depth versions here, and also the self-hosted. So my last bullet point is self-hosted documentation is useful. Like today, you could pip install and get it running. So to conclude, so Pycafe is a platform to create and share Streamlit and other apps. There are many use cases. I covered two of them. Communication and kind of like previews in PRs. It scales infinitely, no server, no cost. And a huge shout out to the Py.cafe team that basically made all of this possible. And if you want, you can try it out at Py.cafe. Feel free to join Discord for feedback. And if you're interested, let me know if you're interested in the private server. That's it. Thank you all.
Very cool, Maarten. You got one request, which is the most classic request. Somebody requested another framework, which I actually never heard of. It's called Fast HTML. Seems like another one. I like Solara for anybody who's looking for a Python-based web server. But yeah, that was super cool. Thanks for showing it. Simba or Pranav, do you have any questions or thoughts on that before we jump to another talk?
Why did you decide to build it?
So basically, I created Solara, this framework, and we needed this communication tool. Like it was very difficult to talk on GitHub about something that is very visual and that always needs a little bit of boilerplate. And you keep sending around these snippets. So we had this need for ourselves. So and then we realized, well, we can support other frameworks. And then actually people were like, oh, actually I could like use this in my company, and that kind of like that's kind of how it grew. So it was a need for ourselves initially.
Super. One thing that I guess I'll cover on my end, and I very much so agree with you, is what you said about files, and that's like I guess the premise of our company. But we'll get to it in a bit.
Yeah, I had the same
Okay, cool.
use case for Solara, right? Like I have Solara in apps that I run, and I don't use like Vercel, and I didn't want to hook it up to Vercel to have like yet another server that runs it on a PR, but just to have it embedded almost into a PR in a way that you can comment. I mean, Maarten, you and I have talked about this, but like crazy cool feature be like if you could comment on the app itself, right? Like the app shows up in a change to the UI in GitHub, so a CI/CD happens instead of getting a link to a Pycafe app. It's like in the PR, and you can comment on a part of the UI and be like, "This is move it," or like, "This doesn't look right," or "This is the wrong style," you know?
Yeah, should I answer the question about fast
Sure.
HTML? Technically possible. I think basically all frameworks are built on top of Tornado, which is Streamlit, ASGI, like Solara, and I think fast HTML is also using ASGI. So in theory, it should be possible to support this. Also, Flask, like Dash, is built on top of Flask. So all of those we can support. It usually requires a little bit of like custom tweaking, but if there's a need for it, we could.
Doesn't that mean that you could also support
absolutely.
like an API? Like you could actually like stand up a fast API app on Pycafe since it's just running ASGI?
Yeah, absolutely. Yeah. Except the only way to reach it is like from within the app. But in
Right.
theory, like fast API works. So we did think about it, like instead of having like with the browser embedded, just remove the browser and only have like well, you can still have the browser. But just as a demo for a fast API, like what would it look like? It would
Or
be
for
fully
like opening
functional.
up an
Yeah.
issue on the fast API repo, right? Like just create a Pycafe. Oh, that's
Yeah.
cool. I might try that
Yeah.
the next time I open up a fast
Yeah.
API issue.
Yeah. Also, Django is supported actually. Like I have an example of Django. I needed to make a fix on Django, so if that is released, then we could support
That's
Django
cool.
as well. It's a
That's
huge
awesome.
community.
Sick. All right, thanks, Maarten. Pranav, you're up next, right?
Yep. Share my
Let's
screen.
learn about Mooncake. Another one of my favorite tools.
I'm glad. Can you guys see my screen, I guess?
Mm-hmm.
Okay, cool. I had initially titled this talk the post LLM data stack, and Ben did a better job of describing what we're doing through Slack, and came up with 0 to 100, which is Postgres and the lake. So let's go with that. First, who are we? We're Mooncake Labs. We are an open source system startup in SF. Today's day, 157 of us being alive, and we're backed by Coastline. We're also a team of ex-MemSQL single store folk. My co-founders, Joe and Cheng, spent close to a decade there. For those of you that aren't familiar, single store is actually hardcore DB world, but it's one of the few truly HTAP systems. And HTAP was, I guess, a fancy way of saying you can run transactional and analytical workloads on the same tables on the same data system. And we didn't stop there. We added hybrid search. That was actually Cheng's team and Cheng's work. And JSON analytics, and this kind of led to this whole like multimodal thing. So Single Store was really like the name of the company, a hackathon project that Joe led, and actually the reason why it became the name of the company, and also what we really believed in. And to build a system like that, it actually does take a decade, or even more than a decade. And still, regardless of a single store kind of existing, we see most enterprises looking something like this, where on the app side, you have many different data systems powering specific workloads. We saw this kind of convergence towards the data lake at many of the big enterprises, and sort of BI and ML ops and LLM ops consolidating on top of the data lake. This was kind of, regardless of there being a single store, we did see this pattern emerge. And in 2025, we can really think about all of the primitives we have to simplify this stack. And that's kind of why we believe we can go to 0. You can start with Postgres and go all the way to 100 with just Postgres and the lake. And that's the belief of our company. And it's kind of based on these primitives. First one, I guess this is for DB people, this is nothing new here, but Postgres' extensibility. We saw this throughout last year, with PG Vector, great JSON support, time series with timescale, full text with Parade DB, and analytics with us. If Postgres can do it, and there is an extension for it, Postgres will probably end up doing it. That's one of the very core primitives of this. The second thing was the lake or lakehouse. And first, let me just kind of be very clear what we mean by that. It's just storing files in object store with some kind of metadata and being able to query them in a stateless, serverless way with any engine. And we see a lot of gravity towards the lakehouse. We're seeing a lot of performance, and we'll get into that, where you actually don't need a stateful system moving data into a proprietary storage format to get really good performance. And now we're seeing a lot more workloads run directly on the lake. Initially, the lake was kind of, in our view, where you ran transformations or MLOps kind of workloads. Soon, the last 2 years, we've seen it's also how you can run really, really fast analytics. It's also where you can store observability and logs in a very cost-efficient way. And also some of the search workloads at massive scale, whether that's vector search with Lancer, TurboPuffer, or full text search with QuickWit, are all lake-based. So storing files in object store now is, kind of a way you can get great performance. You can also get diversity of workloads. The lake is kind of where people want to consolidate their data. The third thing was, this is like kind of our favorite theme, is like there are a lot of very cool in-process serverless stateless engines. And TLDR here is you can stick DuckDB in any workflow super easily in almost any system. We get into this a bit more with what we have done. And the last thing is how you can get really, really good performance with out-of-the-box, state-of-the-art, pretty affordable LLMs. And we're seeing this extremely, extremely common now in the early stage of companies, where things like feature extraction, entity extraction, clustering, summaries, all kind of run through an LLM, and it's an API call away. So with these primitives, Postgres being extremely extensible, the lake having gravity, there are cool in-process serverless engines that you can stick into different workflows, and LLMs kind of make this MLOps, some parts of the MLOps pipeline, a lot simpler for a lot of people. We can kind of imagine a simpler stack. And that's our firm belief. Again, Postgres and the lake is all you need. And let's kind of get into what we mean. First, our project is, PG Mooncake. That's the first thing we did. In Postgres, it's a column store table. We also embed DuckDB in it. So Postgres, for those of you that aren't familiar, it's a great OLTP system. It misses two things to get really good performance for analytics. One is columnar storage, and the second one is a vectorized query execution engine. PG Mooncake brings both. There have been many attempts of analytics in Postgres over the last decade, and they've always either focused on the storage side, like Citus or Timescale, or on the vectorized execution side, like PG DuckDB. And you really do need the combination of both to solve fast analytics. In Postgres, PG Mooncake column store tables behave just like a normal Postgres table. So you get full table semantics. You can run transactional workloads on it, joins with regular Postgres tables, updates, deletes. And we're doubling down on this in our next release, where we'll have full Postgres TAM. So that covers almost the entire surface area. The same tables exist as iceberg or Delta Lake tables outside of Postgres. For those, again, unfamiliar, iceberg and Delta Lake are just metadata layers on top of Parquet files. And these metadata layers are actually really interesting. They give you full table semantics, they give you lineage, they give you governance. But think of what PG Mooncake does is the same tables exist in Postgres as a column store table and exist outside of Postgres as an iceberg or a Delta Lake table. So Postgres table, lake table, kind of one thing. PG Mooncake is live now in Neon. It's coming to Supabase and Azure. There's a cool blog on our architecture, and it's fully open source, MIT license. So give it a shot. And the cool thing with PG Mooncake is we cracked top 10 with ClickBench. And ClickBench is just a benchmark for analytic systems hosted by ClickHouse. And we are the actual fastest system based on Parquet. What I mean by that is all other systems in the top 10 have their own proprietary storage format. PG Mooncake keeps to this open format, Parquet files. And how we do this is by storing detailed Parquet metadata in Postgres. So we actually store no column store data in Postgres. It's just metadata. And on top of the Parquet metadata, we actually compute pretty interesting like row level stats, like min max for each column. And then we aggregate these stacks for each row group to optimize scans. So we store this like advanced metadata. And during query time, we have segment elimination or file skipping. So this can significantly reduce I/O, and you're only looking at the relevant segments or relevant files based on query. So if you have like a time series query, you can easily just restrict the problem space and restrict I/O. And long story short, by cracking top 10 in ClickBench, we kind of showed that fast analytics in Postgres is a reality, and it's also a reality to get really, really good performance with Parquet. And that is going back to our firm belief where data should just be stored in these open formats like Parquet, readable by any engine. And yeah, you can really get some cool stuff with that. This is one of the cool workflows that I really enjoy with PG Mooncake, and it's kind of how most of our customers are using us today. So they add the extension in Postgres. To add the extension in Postgres, it's just create extension PG Mooncake, and create your first column store table with using column store semantics. So it's the same Postgres table semantics, just add a using column store table access method. That creates a column store table in Postgres, and at the same time adds Delta Lake or iceberg metadata into your object store. So here, this table is stored in like an S3 bucket with, let's say the final destination is conversations. Since it's just Parquet files in object store, I can do lots of cool things just outside of Postgres. And the common workflow we're seeing is like people adding arbitrary features or doing ad hoc analytics outside of Postgres, creating a final data set. In this case, let's call it conversations gold, and then reading that through Postgres and serving it. So kind of a poor person's or an easy ways to do kind of feature extraction or feature engineering and then serving it. Just kind of entirely with Postgres, storing data in object store and bringing any execution engine to it. And like Maarten, I'm going to try to do a live demo. So let's see it live. Let me share my screen the right way. So here I have my Neon Postgres where I have the extension loaded. I have a column store table. It's called Reddit comments columnar. It has, let's say, roughly 29 million rows. The first thing I want to show you is like what we mean by fast analytics and like what are the kind of query shapes we're talking about. So in this case, think of, I'll just show you what the data looks like actually. Select star from this, limit to 1. So I have a bunch of Reddit comments. It has author, what's the name of the comment, some controversiality score that was computed, the scores, number of likes, which subreddits it was posted on. It's a very typical just Reddit data set. And let's say I want to find like the top commenters based on some kind of like very basic average score or total score heuristics. I can run an analytic query like this. This would take maybe about 4 or 5 seconds to run on PG Mooncake. It actually will be much faster if we enable S3 Express. So on a hot run, it's about 4 seconds. This kind of query on Postgres regular tables will take close to 3 minutes to run. So that's the kind of 1000x improvement. Postgres wasn't designed to run these kind of query shapes. So it's cool that we can do these in Postgres. But also because I created this column store table, and it's called Reddit comments columnar, it kind of has the data just exists in a bucket in S3. So in this case, it exists in Reddit comments columnar, whatever, this bucket. And what I can do then is just go onto like a random Python environment. And here I have my cursor, just some random Python code, and just query the table as a Delta table with Python. Here as a Delta table, I just point it to my bucket, and create a data frame from it, and then I can do cool things. So here I was like thinking, what is a cool demo to show? I have a bunch of Reddit comments. Let's use like LLMs to just kind of give me a summary of like each user based on the comments and which subreddits they've been on. And I first, do some very basic processing. I for each author, add a list of all of their comments and which subreddits they've been on. And then I can call, GPT 3.5 Turbo here and just say, like, based on all of these comments about a Reddit user, give me a 3-line description. And it does a really funny job about it. So if I look at some of these like random Redditors, like this one, Black Sheep, this Reddit user frequently praises the user's Sexosaurus Rex and is an active participant on the NLF subreddit. Oh, it's pretty cool. And then the final thing I can do is write this to a new Delta Lake table. And that's, again, just write Delta Lake with my final data frame into a new table. In this case, it's MLOps test 4. Great. And it writes it to this table. So that was like I added features, or I computed a new goal data set. I wrote it to a new Delta Lake table. And back in Neon, I can read that table. I can query that table directly. So this is exactly what this table was, what the data frame I was showing you in the past. It's the same data frame, but I can query this with just Postgres. And here I just read the Parquet files from that S3 bucket, and that's it. So that kind of walks you through this workflow where we first have this column store table. You get super fast analytics on it. You can add features outside of Postgres, and then you can finally just serve it with like an iceberg scan or Parquet read Parquet files. So I guess where does that put us as Mooncake? Like, what is Mooncake? And it's a question we kind of ask a lot. We don't really know the full answer, if I'm being completely honest, but we are big believers in the lake. And we believe that people should be storing most of their data in these open formats that are readable by any engine. And we have a couple thoughts here. First is we're seeing a lot more lake native workloads. And what I mean by here is a lot of people are now doing ML ops or LLM ops, and almost every AI application, agent application, whatever you want to call it, this workflow is very, very common, and it's actually very accessible. So we see like a lot more people kind of doing this kind of feature engineering or calling LLMs, or creating embeddings, that being very, very much more accessible. The second thing is we're seeing a lot more lake native workloads online. And what I mean by that is search with Turbo Puffer or Lance with QuickWit. We're seeing a lot more, observability and logs written directly to the lake. And we believe like a secondary indexing framework or secondary index for lake is inevitable, where you'll be able to create full text and vectors, star tree indexes, even hash indexes for point lookups directly on the lake and serve more applications. And you get the benefit of it being completely serverless, scales to infinity, and just kind of one copy of data. And the lake is what kind of enables great DX today and shipping velocity for teams. Covered some of these things, true separation of storage and compute. So you get serverless. It's highly interoperable. You can bring any engine to it. In my case, I brought Daft in that kind of data processing I was doing, but you can bring DuckDB to it, Polaris, Pandas. It works. And a lot of these engines are highly optimized for the lake and are only going to get better, right? Everybody's bet is on this open data stack future. And a nice thought exercise I like doing, and this might be like a bit hand wavy and nebulous, but it's kind of a nice thought, which is like, what would an agent first data system look like? Where LLMs or agents could go in, understand data, query data, try different things, to build a semantic understanding of the world and then answer some nebulous questions. If you were to have a complete blank slate and think of the system from scratch, I think these are the kind of things we'd narrow down to. You kind of want true, again, separation of storage and compute and serverless execution alongside branching of data. And think of the scenario where an LM can spin up like thousands and thousands of different environments and worlds and try thousands of different hypotheses. You probably want some kind of data lineage where, if an agent has done a particular workflow or has written to a new table, you kind of want to go back and see their reasoning and maybe, go back in the previous step and correct their path. You probably need a very rich catalog. And a catalog in this case is a kind of metadata on top of these tables about what they really mean, what the semantics of each column really are. And you want this catalog not just to be readable by humans, but by agents to read, write, update it, and build their knowledge of the data set. You probably want to be able to run Python at scale. So like if you go onto ChatGPT today and just upload a CSV, by default, they're going to write Python against it, right? And kind of load everything into memory and write Python against it. And the bet here is like models are good at Python. They're only going to get better. I guess the only thing is like, how do you run those kind of Python scripts on massive scale data? And the last thing is, I think you probably want a combination of search, both full text and vector search to reduce problem space, filters like regular SQL filters, lookups alongside DuckDB style analytics, and be able to access all of those kind of things through maybe a Python interface that agents can write. And if you look at these list of things, it's actually like just a data lake at the end of the day. It's just very similar to today's data lake. And I think that's kind of very exciting to us. And I know I'm being very nebulous here. We don't really have the answers here, but I think it feels like the lake can provide a great developer experience, and we're seeing great consolidation for humans. And likely the same will hold for the world of agents, where data will be stored in object store in open readable formats, and execution will be completely serverless and stateless on top of it. Yeah, that's it. Try PG Mooncake today. It's fully open source, MIT license. It's coming on to Supabase soon. It's on Neon. And we have a couple things on our V2 roadmap that we'd love some of your thoughts on. Key items right now is full Postgres TAM, logical replication. So instead of you having to batch writes into column store tables, you can point it to a Postgres heap table and have logical replication into a column store table. And then the last thing is small writes. That's really exciting to us, and we can imagine a lot of more tables just being column store tables directly, and people just writing data into it instead of having to batch it. So yeah, would love any thoughts and feedback, and thank you.
That was awesome. I love this concept so deeply that we can actually get to a place where you can be querying data and writing data in an ACID compliant way to an open format. It's the thing that everyone has been talking about for about a decade. It was the thing that single store tried. So it's awesome that you guys are like coming from that world and have that expertise. I've been obviously playing with it so much, and I'm super impressed, and I'm stoked for it to like get to V1 and like be really available and essentially get to the world that you were talking about, where I can just start querying from like a modal instance that scales up with a DuckDB engine that hits my Supabase or whatever Mooncake's hosted service eventually ends up being, to get the metadata to hit S3. I mean, it's incredible. Like it really is it's just very obviously the way the data is going to move. So it's sick. I'm stoked about it.
I'm glad. Yeah, and I know we've had great conversations about this. So yeah, we are really inspired by your feedback, Ben.
It's awesome. Simba, I'm curious if you have any thoughts, because it's so well suited into what Featureform is doing.
Yeah, and I think you'll see that soon, Pranav. I have one question, just knowing some background. Like, it's kind of interesting to me that you mentioned two companies out of single store. You mentioned DuckDB and Neon. You mentioned Coastal backs you, so I imagine that's Nikita. It seems like everyone is kind of coming from single store and betting on Postgres. And it seems like there's kind of this view of the world that you all share given your experiences. And I'm curious to like what that world looks like. Like, is it like a Postgres centric world? Like, I'm just trying to understand why it's kind of interesting that everyone is kind of going Postgres.
It's a good question. I think a couple things here. Like, a lot of it had to do with, I guess, the momentum. Firstly, like for our side was the momentum that we saw Supabase and Neon run with, especially at the early stage company. If you go around SF and ask like any early stage YC company, what are they born on? And it's one of those two. So there's lots of momentum from those two things. I think moving people's operational systems into this like dream hybrid HTAP system is very hard. And I think that's kind of like my belief, which is like meet people where their OLTP is the only kind of way forward. I think expecting people to migrate out of that is pretty unrealistic. The second thing in my worldview was HTAP as we know it today is really, really important, and that's like the single store HTAP. But a very common workflow that we overlooked was like that data processing into serving workflow. And I think that was like I said, like one of the big things that changed my worldview, which is like, it's not just people want analytics, people want to do all of these other weird transformations and feature extraction and all of these cool things that you can't really do in a extremely closed DB environment like single store. So that's kind of like my thinking. I'm not too sure about the others.
Yeah.
Sorry.
Oh, you had one question, which is a great question. It said, "Love the excitement in your tone and presenting. Are you guys hiring?"
Yeah, we are, and I'm glad this came up. Yeah, we're looking to hire a small team here in SF or kind of remote, and yeah, reach out to us, founders@mooncakelabs.com. I think that's my email. Yeah. Yes.
Can I ask a question? So like for technical details. So if you're executing a query, like select max of something against like this table, is it actually using like Postgres or DuckDB
It's
for the
using
execution?
DuckDB today, and yeah.
Okay. Interesting. So is then you're basically expecting some users might expect like Postgres like features, but it's being executed against DuckDB. Like how's the compatibility?
That's exactly
between the
like
two?
what we had to do, which is like route Postgres queries into DuckDB. So for the end user, it's just Postgres queries. And I know Ben has like a perspective that
Nice.
it should also be DuckDB syntax, something like that. But like to the end user, it's just Postgres queries. We route the types and route the queries to DuckDB.
The dream feature that
Impressive.
I was looking for there is, Maarten, actually the opposite. So like, yeah, everything when you hit Mooncake, it's using Postgres syntax, but because Mooncake manages your iceberg or delta tables into your remote storage, what I really would love is the idea that I have my DuckDB locally running or like in some serverless compute, and I run a query, and essentially I say select aggregation whatever over a table. I connect to Mooncake just to get the metadata, the predicate pushdowns. Like it becomes my catalog, and then I can just go directly and stream from S3 or stream from GCS or R2. And so you can get both. Like it's sort of from a feature store perspective, like you're getting your offline and your online store at the same time. Obviously, the online latency isn't like Redis level, but for most people, that's actually like fine. If it's Postgres level latencies, that's a great setup. And so to have it all in this one, it's not one database, it's two locations where data is stored, but it's still this one unified thing is super, super cool to me. Pranav, I had one question, and then we'll let Simba showcase, because I mean it's a great transition. But you were showing that like you could update tables. You have all this metadata statistics. What happens if somebody overrides a table that is cataloged within Mooncake? Like what occurs?
It's a good question. So you can't update the same table. It's why I wrote to a new Delta Lake table. So today we don't have support for writes into the same table outside of Postgres. I'm not sure if we'll get to that very soon, but you can create a new table. In my case, it was like the gold data set and read that through Postgres.
Yeah, I wouldn't even think you'd want to support that. You feel like it could lead to problems.
Yeah, spot on. It's for that reason. Like we all of the metadata is controlled through Postgres, and that's where we compute the statistics.
Exactly. Cool. Okay, Simba, showcase what you can do on
Yeah.
top of an
Can I
iceberg
ask
lakehouse.
one
Oh, yeah,
last
go for it.
question? How are you getting around DuckDB not having pushdown predicates in Iceberg?
Yeah, that's a good question. We're working with their team, and I think we're focused on like there's a lot to like yearn for here, and I think our focus right now is like for the for the Delta Lake world, right? Like I think that's the stance, and eventually like we want to go into S3 tables. Like that's the next PSC we're running, and yeah, we're working with the team on that.
Great. Yeah, I mean, at me at issues because we need that too, and we're happy to help.
Yeah, great.
That's awesome. Okay, Simba, you're up.
I'm up. Let's do it. Good morning, afternoon, evening, everyone. I'm going to talk about something kind of similar, actually. I'm going to be talking about building petabyte scale pipelines with Iceberg. In this example I'm going to use Spark and a few other things, specifically for feature engineering and machine learning. Want to talk a bit about what a normal data science ML workflow kind of looks like today. There's this kind of experimentation paradigm, which a lot of our time is spent in. It's typically in notebooks. We're using polars, pandas, duckdb, choose your flavor. And it's very like science-y. Like there's a lot of testing, a lot of throwing things away when they don't work, a lot of kind of getting these POC-like things working. That's great. And this is actually how a lot of data science is taught, how a lot of data science is done, how a lot of ML is done. But then at any real company that has production machine learning, you then have to get that pipeline into production. And all of a sudden you have to think about all these things that you didn't have to think about before, like monitoring, handling errors, handling changing data, handling features that have to be computed at inference time. So like, is this comment spam? Well, you won't have the comment till the prediction has to get made. So you can't use your Spark job or whatever logic you have. You kind of have to have two separate pipelines. So there's all this work that goes into it. And when you think about streaming, it gets even worse, because then you have to think about backfill, back pressure, all these things that you just never have to consider when you're working in your notebook. And so there's this kind of chasm between the notebook environment and production. And the goal of Featureform is to bridge that chasm. So we have our little feature creatures, and they are the bridge between production and experimentation, making it possible to still work in that kind of lightweight notebook style to test things, make sure things are working, but make it much easier to get that in production. Because we've all kind of been in this sort of situation before. And just to add a bit more clarity of what I mean, with most companies we work with, we see one of two things. Either the data scientists themselves have to go learn how to deploy and maintain production grade data pipelines themselves, as well as all the other stuff they have to do. And there are some people who can do it. There's kind of these unicorns who can kind of like be, production grade data engineers and also, amazing data scientists as well. Some of those exist. But most of the time, if you're a data scientist, your specialty is data science. And if you get into the intricacies of production data engineering, it's out of scope. So what we see more of is that data science teams kind of pass their notebooks to a data eng team or some ML eng team, whose job it becomes to take this notebook, take the logic, and essentially rewrite it, transpile it into production code. And we think that's wrong. We think that data scientists, one, should be able to deploy their own and should be kind of managing and have the freedom to try things, release things, iterate by themselves without being dependent on another team. But the current workflow, the current tools are really not conducive to that without Featureform. You start, and then there's more to it, right? When like even if you get these things in production, there's documentation issues. You get these features in production, and you start worrying about having untitled notebooks that you are deploying to production maybe directly, or at least like using to like as your basis with df final, feature table v7 and Snowflake. You have these shell scripts that people use and ad hoc kind of just jobs and YAML files that are all being used to kind of MacGyver this feature into production somehow. And to make it all worse, it's probably not really well documented. And it gets even worse because then it's in production and you have these features and there's no monitoring on them. So there are many, many stories of companies that have had their models break down, or the worst is when they get slightly worse, like they're like 5% worse. And if it's like a recommendation system that literally directly impacts revenue or a fraud model. But there is no drift monitoring. Like there's no way to see how the features are changing and how that's affecting the model. So you can see that maybe the model's doing worse, but then it becomes this kind of mad dash of figuring out why. Where if you had proper feature monitoring, drift monitoring, which like Databricks isn't going to have feature drift monitoring, you kind of lose all this. So this isn't kind of new problems, and there's kind of a class of things called feature stores that were kind of built to solve a set of these problems. The common workflow that we've seen around feature stores, or like let's call it architecture we've seen, is very literal. Like it's literally a place where features are stored. So you write your transformations and whatever, and then you kind of like pipe your features into this feature store that you can use to serve for training and inference. The issue here is that the transformations themselves, like the kind of basis of these features, is not actually part of the feature definition. So the features kind of change without the store. All the things I talked about, like getting your pipelines in production, having to deal with incremental pipelines, streaming pipelines, monitoring, all that stuff is kind of out of scope here of a feature store. So we rethought of it. We call it the virtual feature store, where rather it's more of a like orchestrator and metadata layer that sits above your infrastructure, and it gives you everything you'd expect from a feature platform, but running on your infrastructure. And using open table formats all the way through it. So everything is iceberg under the hood, which I'll get into. So how it works, and I'll actually give a live demo. We're doing 3 live demos today, it sounds like, is you define your features as SQL, PySpark, whatever you're using. You kind of give that to Featureform. Featureform will then orchestrate it, build a feature, continue to update it, provide all the other things I talked about, from versioning, documentation, search and discovery, monitoring, etc. But it's all kind of running on your stuff. So Featureform is storing the metadata and orchestrating. So yeah, let me maybe give a quick demo to show what that looks like. What does that actually mean? So here I have a little notebook running. I have a Featureform running locally. I've connected to it. I will have registered, we call them providers, things like Spark or Dynamo or Snowflake or Postgres or BigQuery, whatever. And I can now define things on them. I can do things like register tables, like my primary data sets. I can register files. I can register whatever I want, really. Everything in Featureform can be retrieved as a data frame. So everything is interoperable data frames. So that experimentation paradigm is still really easy. When building features, let's find a more interesting one. So here I have a feature where it's called %balance. I have transactions as an input. I create a new column, balance %, which is the transaction amount of a transaction divided by the balance of the customer's balance. If the customer balance is 0, which would result in a divide by 0, I just do 75. If I run this and apply it, you'll see that it runs, and it is now in Featureform. So if I go to the here, I can see so I have my providers, which I talked about. I have my data sets. So if I go to the data set %balance, I can see that it ran. I can see the different versions of it. I can see any documentation tied to it. I can preview it. I can see the runs. Like I can see the Spark jobs or BigQuery jobs or whatever that ran to actually build this thing. And I can follow the lineage. So I kind of get all of this. The other really nice thing is if I run it again, like I did, it handles equivalence for you. So if something has the same logic as before, it will reuse something that already exists. Where this is valuable, part of what I wanted to Featureform was Terraform for features. So the declarative way where I could have like a directory of my feature definitions, I can apply it, and all the changes that I make to that directory kind of get applied to production. So all my features can change, everything can happen. The things that worried me were, 1, like breaking features in production that already exist, and 2, like I don't want to rerun things, and I don't want like kind of use scripts to like deploy things directly. It just was way too messy. There was just way too much pain there. So Featureform, I kind of defined these things. It will handle equivalence. So if nothing's changed, it won't do anything. If something's changed, it creates a new version. So for example, if I was to like turn this to 100, or yeah, like 100, and run this again and apply it, now it's actually going to run. And this is actually running on Spark in this situation on Databricks. And if I go to the UI, and I'm going to refresh this, you can actually see the new version. You can see that it's running, and you can see the change. And then finally, just to go quick here, everything in Featureform, you can define your training sets as like features, labels. Everything you build can be retrieved as a data frame. So I can get my training set, turn it into a data frame, train on it. And for inference, I specified that these features are in Dynamo. So I can call, I want these features for this user, and it will retrieve those out of Dynamo for me. It also handled the copy from Iceberg to Dynamo and all that as well. Last little bit I want to talk about is how we use Iceberg, or how we use Iceberg, because it's actually very relevant given the last talk. Originally, when we built Featureform, we had different kind of code paths for each provider. The issue we had was that there was kind of some specialization. Even Spark on Kubernetes or EMR or Databricks were all very different. And we could only do so much optimization because they were just, again, so different. So it's still lots of the promise that we had of like kind of, hey, this is just going to work super fast anywhere, we couldn't quite achieve. We kind of still had to push some of it, at least at like, massive terabyte, petabyte scale, back to the user to figure out. And then we started worrying about all these other issues that kind of came up from having our own sort of table format. What Iceberg gave us, what Iceberg is, for those who don't know, is it's essentially taking data files, putting them in parquets, and then having pointers. So like, hey, these data files together make up the table. As the table changes, it creates a new metadata file. It's like a new version, and it has all the new pointers, including some files which can be deletion files. So like you kind of rebuild the table, and it kind of appends deltas at each change. That's, in short, how Iceberg works. But the other thing that gives you is push down predicates, which is like an index. So I can say, hey, I want to put, sort these by this column. So then it might bucket them for me. It might say, hey, okay, names A through C are in this directory, D through F are in this directory. And for every directory, it will bucket in that way, which creates an index. Now, if I write a query or a join, if the processing engine is smart enough, it can skip things. Like if I was to join two tables without this, Spark would read everything for both tables. It would shuffle them together to kind of put similar things, so like A for C on the same node. And it just becomes a very expensive operation. With Iceberg, it knows that, hey, on this file, these data kind of overlap, they match, let's put them on the same node immediately. So it's significantly faster. And the nice thing that we've benefited from is that everyone is moving into kind of Iceberg support. So for Spark, for Snowflake, for ClickHouse, for BigQuery, all of them now support Iceberg. So in all these situations, we write Iceberg and we focus on really optimizing the Iceberg. These huge levels and take full advantage of them in a way that's generic. So we don't have to build for every single provider anymore. We can just build for Iceberg. Yeah, when you bring it all together, what it does is it unlocks data engineering. So as a data scientist, you get all the power of everything I just talked about without having to know what merge on read means in Iceberg, without having to know all these intricacies of Spark. All you have to do is define your features as PySpark or SQL and let Featureform handle the rest. That's all I got.
That's awesome. I love it. I have a bunch of questions, but I will save mine for the end because I like Pranav and Maarten, your guys' questions have been awesome. Do you guys have any to start?
I just want to say, like, I was super impressed with the like seeing the code in the the notebook. I was like, is it for real? And like seeing the code like in your system, that yeah, I like
Beautiful.
that a lot.
Yeah, a lot of hard work, a lot of sweat, blood, and tears to get there, as you guys both know.
So you do a really good job explaining what iceberg is. Like,
Yeah, it's lots of practice. I feel like iceberg's one of those things everyone is like, oh yeah, we want one of those, and then it's like, why? And they're like, we don't know what it is, but
Yeah. So you handle all of tell me if this is right or wrong. You handle reading and writing through the execution engine that supports Iceberg, right? Look, which is why, for example, DuckDB isn't like a native provider in your system. Is that right?
No, we actually do support. Well, maybe I'm gonna like answer a question I think you asked. I might have misunderstood it, but everything gets written to Iceberg when you do client.dataframe on the client, like I kind of showed for that moment. It's actually reading the Iceberg table directly from S3 or wherever it is. It's not actually going through the execution engine, so it's significantly faster and allows us again take advantage of those pushdown predicates. The only reason we don't have DuckDB support is on the client side. There's two things. One is just time. It's something that's kind of been asked for, but not strongly enough to like.
Yeah.
So if anyone wants to build it, we'd happily help you. It is open source, by the way. It's open core. I don't know if I mentioned that. The other bit, which I talked to Pranav about, which is a big one, is that DuckDB doesn't support pushdown predicates on Iceberg, which means that all the promises I just told you about the indexing doesn't actually work on DuckDB right now. I know they're working on it. But anyway, so that's another bit, but I would say it's more the first bit. It's just time. There's nothing about Featureform, but inherently doesn't allow for DuckDB support.
So where are, like, for example, what level of openness does Featureform provide? For example, like Daft is a data frame library that does support like reading and writing to Delta, and I think also to Iceberg. If you were to write, for example, in Featureform, you wanted to do a transformation that was data frame native, it would have to be a Spark transformation, as far as I can tell, right? And not sorry, I don't mean to say you have to write it in Spark. I'm saying when you tag the transformation, you define it as a Spark transformation, then you can pull in the data frame, right?
Yeah, so you specify the execution engine. So everything actually does read and write Iceberg, but like for example, BigQuery. Like in BigQuery, we write Iceberg, but the problem with BigQuery is it doesn't support data frame transformations. So you can't run a
Right.
data frame transformation on BigQuery because it just doesn't have that support. Something like Daft would be totally usable. It just, again, just a backend that would need to be implemented. There's kind of a explosion of permutations of things that we have to build. So we kind of try to focus on a few.
But that's what I was meaning by, in terms of like opening the internals. So if I defined, for example, a Spark engine that was just local, right? But I routed it through Daft locally. Like, wouldn't that would be fine as well? I define it as a Spark transformation, but until Daft is a first class citizen, like, get the data frame into Daft through Spark, do your Daft transformations, and then push it back out to Iceberg, maybe through your local Spark where the serialization is very low.
Yeah, you could totally go that route. The other thing is like all these things are just Iceberg tables in S3 or wherever you have it. So like in the end, you can just skip feature form entirely and just write a transformation step outside the feature form, which we've seen, and then like re-register that thing as a primary. We see that not typically within the pipeline, but typically before the pipeline, where people say, oh, okay, like we use Airflow for our data eng, which is great. Airflow is really powerful for certain things, or prefect or whatever. But then for ML people, like the workflow of machine learning is very different from the workflow of data eng. It's way more, you just do more stuff, and it's a lot more lightweight, or you want it to be more lightweight, even though it's the same data and arguably harder. So it's like kind of a hard challenge. So Featureform is more oriented towards the kind of that workflow. So a lot of time we'll see Airflow or prefect in a Featureform at the end. But they'll use kind of Iceberg as that handoff point.
Right. Pranav, did you have a question? Did I cut you off?
No.
Okay. We're a little over, but I think it was worth it. That was really fun. For anybody watching, I mean, these are all open source tools, right? That's why we had them on. They all have like real product offerings. So as you scale, you can continue to scale with the companies, but they're all open source. I love all of them. I recommend trying them all out. They're really, really new ways to avoid having to go with like the GCP or AWS version of these tools, which are just never as good. Like, it's so much better to have these custom built, like really focused teams on one problem, at least in my opinion. But yeah, thank you all for coming on. This was really fun. I appreciate it.
Thank you.
Yeah.
Thanks for the chance to talk
Yeah.
here, Ben.
Awesome.
Super fun.
All right.